So let me turn to Earl Hackett and his 3D printed CAD developed structure that he's building. So Earl, thank you for doing this.
Okay, there I am. Let's see. So if I get this guy fired up here, start. There we go. Wait a minute. Got to share a screen first. Share screen. Share. Okay, see a bunch of rhinos there?
Yes, I do.
Yep.
Okay, there we go. Got the right screen, got the right thing. Okay, we're going to continue with the bunkhouse. And I've run into enough problems that more than I wanted to know about. And basically, every manufacturing process has a set of design rules. I've used to know the ones for injection molding for plastics, injection molding for thermoset elastomers. Been a long time since I did that kind of stuff. 3D printing, as far as I know, doesn't have a set of design rules. And these are design rules that specify, for example, you'll often see on a model a plastic sheet, a plastic surface with a stud stuck to it that you run a screw into to hold it onto something. Well, the design rules will go so far as to tell you what the radius of the fillet should be at the bottom of that stub, so you don't disturb the surface that it's stuck to. Found that doesn't exist in 3D printing, because if you listen to the manufacturers, you take the file, you put it in the machine, push the button, walk away, come back, magic happens, and oh, there's the magical, pull it out, and you got a part. Well, that's fine for small things, but when you're working with some big things, it doesn't quite work that way. And you'll see, this is the model I'm building. It's the bunkhouse of Thurmond, West Virginia. It's long since disappeared. I broke it into 3 pieces, and I've rebuilt all 3 of them at least twice now. The important thing is with interfaces, when you're putting parts together, they got to fit. And one of the problems I've run into that is a real bugger is warping due to uneven exposure. Remember back when I started this, I talked about the resolution target. When I showed that to you, this thing was perfectly flat. And that's what it looks like today, 4 weeks later. What happened, when I put it in the post-cure unit, it was still attached to the base. So the top got a full dose of ultraviolet, cured it up good and solid, and then I cut it off the base. Well, the bottom, of course, it was in shadow. It got very little. When you cure something, when you polymerize something, it shrinks a little bit. And when it does, it tends to put stress on that one surface, and it causes it to curve because it wants to make that surface shorter. Well, that's pretty bad. I made my roof and had the same problem. I thought that I was getting it uniformly exposed, but this is a fairly thin, it's only half a millimeter thick on the basic roof. It had some supports in there. But what happened, as far as I can tell, this is a wild guess on my part. I put it in the post-cure unit standing up. Well, if light came in from an angle like this, it'd reflect off of here, come over here, and hit this surface. So this surface is getting not only the incident light it's supposed to get, it's also getting reflected light from the opposite surface. So this surface underneath here got a little more energy than this one, because here the light would come down and just bounce off and go away. And so this lower surface shrunk. And you can see it's not even close to fitting on the building. So I did a little experiment. I took two sets of 1 by 3 inch panels, and I made them 1, 2, 3, and 4 inches thick, 4 millimeters thick, rather. And then cured them. One set was cured in this formation like this. It was sitting on its base. The object was to have this area, these inner surfaces in shadow, with the outer surface getting a full dose. The other set was lined up side by side, and everybody got the same thing. When it was all over, this 1 mil panel, this guy over here is 1 millimeter thick. He showed, after about a week, he showed a little bit of warpage. Not too bad, but it definitely was bent. Everything else was just flat as a pancake. Not a problem. So I'm starting to try to figure out why things bend and twist and warp. Well, yeah, the unshaded 1 millimeter panel was perfectly flat, and the shaded panel, very slight warpage. Even slight warpage is too much because the thing has to fit. So to prevent distortion of unsupported large sheets, one, you want the sheet thickness to be a minimum of 2 millimeters, especially if you're building an end of a building where you have 3 sides and it's, there's no way you can get uniform exposure there. So you want a good, thick, solid sheet so it can resist that compression forces on the outer surface. And you want the supports to be on the edge of a sheet if possible, with vertical positioning during the curing stage. So here's what I wound up with. I decided I'm going to build a frame and put on a conventional polystyrene roof with, it's going to be a tar paper roof. So put on some polystyrene and put simulated tar paper on it. But these are all fairly substantial structures. These are 2 millimeters thick and 3 millimeters of 2 millimeters wide and 3 millimeters thick structures. And I built it in 3 pieces this time instead of just 2. And I made a plug and socket joint. This is the plug. With these end pieces here, this had to be the surface that was going to get the support. So this is an ugly surface, and I had to clean it up with a little disc sander on my dental drill. And you can see that this is still, I left that ugly because who cares? So this is what you had. Now I left a clearance of about 0.5 millimeter, 0.5 millimeters between all the surfaces, all 3 surfaces. And it turned out to be almost good enough, but not quite. So I had to do a little bit of filing on the surface of the plug so you get a nice snug fit into the socket that's sitting on this surface over here. When you're all done, it's fit very nicely on top of the building. The nice thing about the plug and socket arrangement is that they don't have to be shoved in all the way. You have a lot of leeway as to where this thing is going to be positioned, because something this long is going to show shrinkage. And remember, we made this building in 2 pieces. I like to believe that I had it exactly the right length end to end, but it probably isn't. So having that ability to slide this joint back and forth just a little bit to get these end pieces lined up just where you want them is a real big advantage. Makes life a lot easier. So once you have it set up like this, you take a little CA, put a drop of CA in here, a drop of CA there, and that's it. The thing is solid as a rock. Now, what I'll do when I put the styrene on, I'll make sure that we have the styrene bridges these areas here, and that'll add some extra strength to the structure. So that was my learning for the last week and a half. It was painful, but we got there. And I came to the conclusion. Well, Jim asked me to do this presentation. He said, I'll give you 5 weeks. And I said, oh gosh, I don't know how to fill up 5 weeks. It'll only take 3. So I had never built anything like this before. So I thought it's just, you put the thing in it, push the button, out comes the part, stick it together. Oh yeah, right. We need a set of design rules for 3D printing, and I'm working, and you may need a set of design rules for each printer and each resin that you're working with. Everybody's going to have a different combination of these things, but I'm going to put together for my own enlightenment. It's going to be a set of design rules, and I hope we'll be able to get them published. We'll get them published up on the NewTrack's website. That will give you a good design for you. Well, at least in this case, I'll put up the test samples and everything else that I use to develop them. But also, the actual numbers will be for my Elegoo printer and the Cereatech build resins that I use. I know I'm going to find more problems. I'm going to build some much bigger structures. The engine house is about 14 by 28 inches. And it's part of it's on pilings. It's going to be an interesting build. So that's where I am right now. Am I going backwards here? Next week, I'm going to have some fun installing windows and painting the model. I hope we'll get on with it, and that's it for tonight. Anybody have any questions? Yeah,
Anybody have any questions for Earl?
Gonna make a nice building when you're done, Earl.
It's coming out really nice. I'm very pleased with it.
Earl, I don't have a question. I do have a suggestion. If you want to eliminate some of the shrinkage and get better penetration on your cure, look into a translucent or a transparent resin. That is all I use anymore.
Yeah, I have, and because of some of the applications, they get a little more brittle than I like. This is a very tough resin, and it has about a 7% elongation to break, and tensile strength is around 7,000 pounds per square inch. So it's a pretty tough resin. And when you're working with some real tiny parts, handrails and stuff like that, you really need something like that to they're still delicate, but at least you just touch them. They don't fly off like I have with some of the other resins I've used. So that's what I mean. You're probably going to have a set of design rules for every printer. Everybody's going to have to build their own rules for themselves, because they're going to be using a different resin, a different printer, but the test methods are going to be the same. And that's what I'm going to be working on, is coming up with simple test methods where you can make a couple parts, fit them together, and see what your clearances actually have to be. And they'll be very simple to do.
Yeah, I have a question. What does your curing tank look like, or however you're curing it?
My curing tank, it's a galvanized metal bucket, and I got 2 strings of 405 emitting LEDs from Amazon for about $20, and they're taped around the inside in a big spiral. Let me see if I can find a picture of that real quick. Put this down because I made it myself. The actual cure time is about 2 minutes. It goes really fast because the light is so intense. I don't know if I can find it real quick. Photos, let me see. Oh, here we are. There it is. That's my curing tank.
You gotta share it.
Oh, I'm not sharing? Oh, I'm sorry. Escape, got to share again. Okay, share
No
screen.
problem, Earl.
Share screen. Here it comes.
Ooh, that nice hippo.
There you go.
Wow.
So when you put something in there, it's pretty intense light. I put a lid on it when I'm actually curing stuff, because you don't want to have, there's a lot of light in there, and it really warms the thing up.
Can you over cure it?
I leave it in for about 2 minutes. That's about all it takes. Sometimes I'll leave it in for 3 if it's a real complicated part. But I have run some stress strain tests on them, and 2 minutes seems to be about the right number.
Earl, I can't thank you enough for putting together the information that we're going to post on the website, because I think that's going to help a lot of people try to figure out, what they need to start with at least.
Yeah, you really, I thought this was going to be a pretty easy project, but I'll tell you, you don't want to start. You really need to do a lot of background work and research before you start something like this. Because like I said, I think I've made at least 2 of each of those 6 parts. And I think I made 3 of 2 of them because they just weren't acceptable. So you really need to, that's why I think we really need to have some test methods and stuff so you can develop design rules for your own operation.